Hi, my name is Peck from the University of California, Riverside, and I'd like to tell you about the work that our lab has conducted towards designing and building a next-generation calorimeter for muons and neutrons, which could be used here at Jefferson Lab to detect minimum ionizing particles in the far forward region. This upgrade would add to previous work done at places like Hera on leaning neutron hadronization, and at Hermes looking for muon decays of charmed mesons, which are highly sensitive to the gluon distribution functions. We've been testing out some newer technologies which will allow us to propose and test an effective and cost-efficient design over the next couple of years. The active volume of our calorimeter is made from a scintillating plastic doped with PPO such that it fluoresces in the ultraviolet, which can be captured by an optical fiber and delivered to an array of silicon photomultipliers, which can give precise timing and fluorescent flux information. This design is much more compact, operationally simpler, and more cost-effective than the traditional photomultipliers, and more effective at detecting minimum ionizing radiation compared to the electromagnetic calorimeters currently in use in Class 12. This detector will also work at higher energies as Jefferson Lab looks at possible charm physics at 22 GeV and in possible future projects like the upcoming EIC. We've already seen some applications for doing high-X measurements to provide references for planned EIC experiments. So far, we've been experimenting using a single scintillating bar set up inside a dark box to intercept passing muons from cosmic rays. Our initial results are promising as we've been able to detect an energy distribution which looks like the expected Landau distribution of the stray cosmic rays that we've been testing with. We are designing the compact circuits which will allow us to efficiently scale up the size of our prototype, and we've already been quite successful at calibrating the response seen from the silicon photomultipliers. We have a good understanding of the dynamic range, timing, and resolution that we'll be able to achieve using the readout electronics, and our next steps will be to characterize the responsivity of the plastic active volume in conjunction with detailed GEM-C simulations. Thank you to Jefferson Lab for hosting and supporting the class, and to the Department of Energy for funding of this research.